In this video, we take a look at some basic solving equation skills, which is important for us because a big theme of this course is algebra, and ultimately, there are going to be some equations that we can't solve with flowcharts. So let's remind ourselves that solving means finding the value or values of the unknown that make the statement or the equation true. We've already talked about how solving means breaking down the equation by unbuilding it. When we talk about solving, we can also think of this as breaking down the equation to make it simpler. We remind ourselves that whatever we change on one side of the equation must happen on both sides, and that it's very important to show your thinking. When we talk about showing your thinking, we can think of this as creating a map for how you found your answer, which is going to let you be able to redo that problem or similar problems much faster. And this is a good point to remind ourselves that in this course, if we are asked specifically to solve, that a guess and check approach is not worth points. When we solve, we've already mentioned breaking down the equation by building it. Our equation was built following the order of operations, so we are going to unbuild the equation following the reverse order of operations. Let's start with this example. If we think about our order of operations, when we build the equation, we would start with k, divide it by 2, and then subtract 15. So in order to unbuild the equation, the very first thing that we do is to undo subtracting by 15. We'll add 15 to each side of the equation. You can show that now we have 0 being added to k divided by 2, but we really don't have to. Now let's see, we need to undo dividing that k by 2. Let's multiply each side of the equation by 2. And we solve to find out that k is equal to 50. This equation is a fairly straightforward one, but sometimes it makes students a little bit uncomfortable that the variable is over on the right-hand side. Keep in mind with our commutative property, we can write this equation in several different ways. 27 could be equal to 5y adding 7, or it could be equal to 7 adding 5y, and it doesn't matter which piece we put on the left-hand side of the equal symbol and which piece we put on the right-hand side of the equal symbol. So when we build this equation, we start with y, multiply it by 5, and add 7. In order to solve, we're going to have to undo the adding and then undo the multiplying. So let's subtract 7 from each side of the equation. Again, we don't have to show the 0 that's left if we don't want to. We're going to divide each side of the equation by 5 and end up finding out that 4 must be equal to y. Now here's an equation that gives us students a lot of trouble when we're subtracting some groups of the variable. It might be helpful here to keep in mind which pieces of our equation are positive and which pieces are negative, and if you like, rewrite the equation to show that we have negative 2w's and positive 41's. When we solve, once we recognize that this is a positive 40, we're going to subtract 40 from each side, and then we have to undo multiplying by negative 2, so we have to divide by negative 2, and make sure that we actually divide through by negative 2, not just a 2, and solve to find that w must be equal to 13. This equation would make some students a lot more uncomfortable because of the fractions. But don't worry, we can still solve. When we look at this, we would build this equation taking a, multiply by 9, add 2, and then divide by 10. So the first thing that we will do to solve is to undo dividing by 10. We're going to multiply both sides by 10. The division disappears from the left-hand side, and 1/2 multiplied by 10 is 5. Now we're going to undo the addition, subtracting 2 from each side. 9a must be equal to 3. Divide each side by 9. Let's look at that fraction. It's not in lowest terms, which is an expectation of this course. We can rewrite that as 1/3, and if we need to, use our graphing calculators to help us out. In this last example, you'll notice that I didn't show what was done to each side of the equation. If it helps you to show multiplying by 10, subtracting 2, dividing by 9, absolutely show that every time. But if you're a student who's more comfortable with algebra, you are not expected to show those thinking processes if you don't have to. So our end goals here for this lesson are to be able to use algebraic techniques to solve equations that have just one variable in them and show your thinking as you do so.